Good morning, everyone. So, this morning, I want to take a break from my normal content just because I've been fascinated, as many of you probably have, with this object, 3i Atlas, that's come into our solar system. And, there's been all kinds of speculation back and forth about whether this object could, at least at some low probability, potentially be an artificial object. And I'm kind of frustrated, I guess, with the state of our scientific community on this, with the direction we're going, with the direction NASA's taken. Not in from the sense of, I feel like they're being overly closed-minded or biased towards a natural origin, or not necessarily, right? But there are. It's impossible to label this thing 100% right now, and that's why we have so many instruments on Mars that are even currently taking pictures, taking scans of this thing, trying to grab uh, spectronomical information that we didn't have potentially, or clearer pictures in different wavelengths of light, and just all kinds of different scans that are going on these different orbiters and rovers and other things that we have on Mars, around Mars. And I think that we potentially, as a species, might be missing an opportunity. Um, as many of you may know or may not know, for at least the last century, roughly, we've been sending out radio and then television signals weekly, but we've been sending that information out around our planet, right, to allow people to listen and watch and entertain themselves with television and radio broadcasts. And since the beginning of those transmissions, those have leaked out, right, past our atmosphere, have gone out into space weekly, but have gone out into space in different directions for a long time now. And it's my understanding that those signals are present today, that there's no way to muffle those to where they don't leave our solar system, don't penetrate out into space. So, in a passive way, we're already transmitting out into space all these weak signals. And one of the anomalies with this object is that it's come approximately, from a very, very similar direction that the famous WOW signal we received back in 1977 came from, to within a few degrees, I think. And that's common knowledge now. It's been shared. It's been speculated about by Avi Loeb and others. And I was watching this video this morning, and he's still making a pretty strong case that not that this thing is artificial. Okay, I don't want to misnomer what he's saying or mislabel it or castigate him for saying it. What he's saying is there's a lot of anomalies with this object that point to something different and new, and potentially, very, very small, potentially an artificial origin for this object. And I feel like if that's the case, and we already have all these weak transmissions going out into space, that there's an opportunity here. I'm just going to play the first part of this to a specific point where I stopped it and kind of had this thought. And I'm sure others have already gotten to this point and are wondering the same thing that I am. So let me go ahead and play this. Hopefully the audio gets picked up by my recorder, but we're going to go ahead and play this for a little bit.
Thank you so much. It's a special day.
It is. It is really special. The new year, and in the Hebrew calendar, at least, Shana Tova, all of our Jewish friends and non-Jewish friends out there. Avi, it's been an incredible summer since we first started talking about this majestic, mysterious object that some say is possibly alien technology. Some say it's ordinary, prosaic meteors or comets, and we even have some meteorites. I'll be giving those away later. Stay tuned for that. But Avi, first things first, why is today so special? What happened today with respect to everybody's favorite interstellar object, 3i Atlas?
Excuse me for a moment. Would you like to see something
Huge.
Three,
Good old
two,
YouTube.
one.
A lot of people have questions about how strong our permanent set of teeth in 20.
What's special is that a picture is worth 1,000 words, and we are about to get images of 3i Atlas that are the best resolution ever, simply because it comes so close to Mars. Now, it will be difficult to observe it during the month of October from Earth because the sun will be between us and the 3i Atlas, perhaps for a reason, but it comes today closest to Mars within 29 million kilometers. And there are orbiters around Mars that could look at it. For example, the HiRISE camera on board the Mars Reconnaissance Orbiter that NASA put near Mars can take images and with a spatial resolution of 30 kilometers per pixel, and that's the highest yet for 3i Atlas. We don't know how big the nucleus of 3i Atlas is. I wrote a paper last week that showed that it must be bigger than 5 kilometers because we looked at more than 4,000 observations from 227 observatories around the globe that monitored 3i Atlas over the past 4.5 months. And we put the motion of 3i Atlas on the sky as a function of time, compared it to what is expected from a trajectory that is sculpted just by gravity. And we found no difference whatsoever, meaning that we can put a very tight limit on any non-gravitational acceleration. And that means that it means that the object is very massive because we do see that it's losing about 150 kilograms per second based on the Webb telescope data. And it's mostly coming in the direction of the sun, from the sun-facing side, because the Hubble Space Telescope took an image that showed a jet 10 times longer than it is wide, coming in the direction of the sun, of scattered sunlight. And so altogether, that should give a recoil to an object if it's low mass. But the fact that we haven't detected any recoil, any deviation from a gravitational trajectory, means that the object is very massive, more massive than 33 billion tons. And
So I just want to take a minute here and explain kind of what he's saying. So what they're saying is that this object it has to be bigger than what we initially thought. And the reason for that is the whole time this thing has been coming in towards the sun, it's been off-gassing in the direction of the sun. So there's a plume that's in front of it that's headed towards the sun and not away. And what they're saying is with that sublimation, with that off-gassing, that should produce like a thrust, right, opposite the gravitational pull of the sun. And so we should see this object, as it's getting closer, affected by that. Its trajectory affected, its speed affected by that, right? To see it slow down, right? And what they're saying is they've seen almost no deviation in the acceleration, in the pull of this object as it's coming in. So what that means is they've done the math to essentially say, well, how big does this object need to be? How dense does it need to be in order for the gravitational impact of the sun to not and the gravitational impact of the sun, the solar wind versus the sublimation of this thing, for there not to be any deviation, right, from just what would be a predicted norm if we're just talking about the pull of the sun without any off-gassing in the direction of the sun. And it doesn't add up. It doesn't add up in the sense that this object, if it were as small as we first thought, like 1 kilometer to 5 kilometers, it should be slowing slightly or deviating slightly from those predicted norms based on the math, right, of the solar wind and everything else that's going on. And they're not seeing that. So what he's saying is that doesn't make sense, right? Unless this object is bigger, that doesn't make sense. The other alternative to it being bigger would be it's somehow able to produce some force that's preventing it from being affected by some field effect or something that's preventing it from being affected by the off-gassing, right, to slow it down. So either one of those, right, is very provocative, right? Either way, it's either much bigger than we thought, or it has some mechanism by which it's not behaving the way we would expect, based on initial size estimates. So that's where they're getting this new size estimate from, and density estimate from, is it's from them doing the mathematics calculations to look at those numbers and compare them. And they've gone across thousands of different different observations of this thing from all these different telescopes around the world up to the point where it's in the sun's glare and they can't get a good look at it.
Solid density, that means bigger than 5 kilometers. That's bigger than the width of Manhattan Island. But it could be much bigger than that. It could be up to 46 kilometers in diameter based on the Spherex data that was obtained a couple of months ago. And so we don't know what its actual diameter is. And of course, the mass scales as diameter cubed. So it's really important to use the brightest pixel in the high-rise image to infer the surface area that is reflecting sunlight of the nucleus of 3I Atlas. So that's coming up. And then there is also the high-resolution stereo camera on board ESA's, the European Space Agency's Mars Express. That's expected to capture lower resolution images. Then we have the color and stereo surface imaging system, CASIS, on board ESA's ExoMars Trace Gas Orbiter. And again, we will get color images here and also stereo views, helping to learn about the composition analysis through spectroscopy. There is also a spectrograph on that mission. And then there would be ultraviolet imaging that could be obtained from the MAVEN spacecraft that NASA launched near Mars. And there would be additional images reported probably from the camera on board China's Tianwen-1 spacecraft, as well as the HOPE orbiter of the UAE's Emirates Mars mission. So lots of instruments, and obviously data is the best way for us to figure out the nature of this object, because as you often say, Brian, you don't judge a book by its cover. You know, we saw some gas around this object that came from the skin of the object. We shouldn't assume that what lies inside is dictated by what we see coming from the skin of the object.
You said something very provocative in the very beginning. I can't let that go. And you said we won't be able to really observe
So here's the crux of it right here.
it from Earth at its closest approach. And you said perhaps there's a reason for that. Now, this may or may not venture into a techno-signature discussion. So first, why did you say that? And second of all, how close will it get to be, to the Earth, actually?
Right. So to the Earth, it will not come very close because we are on the other side of the sun right now. So the closest it will get is in the middle of December, just before Christmas. And at that point, it will be more than double the Earth-Sun separation. So it never gets close to Earth if it follows this path. However, if it's a technological object, it might maneuver, taking advantage of the gravitational assist when it comes closest to the sun. So when it gets closest to the sun, if it's a comet of natural origin, it might erupt in a flare of outgassing and maybe even break up into pieces of ice. However, if it's technological, it might maneuver. And then if it comes on the other side of the sun in a completely different trajectory, I think the financial markets may crash. Now, let me say a few words about what we believe to be the anomalies of this object. So, like in any blind date, encounters with interstellar objects can result in deal breakers, meaning non-negotiable behavior. And I separate the anomalies of 3I Atlas into two classes. Those that could be alleviated.
Now, what he's talking about here, where he separates the anomalous features of 3I Atlas, this is in his latest paper, I believe. if you go on Google, you can look up his latest paper. It's worth the read if you have time. I'm not a math geek or anything, so some of the calculation, I'm just a normal everyday person, so the figures and calculations in there, some of it's a little bit beyond me, but as far as like the conclusions and stuff, it's worth a read and worth thinking about, I guess. So this is where he's pulling this information from.
Or explained away with upcoming data, let's say from the Mars orbiters, and those that will never go away. They will remain puzzling forever. So let's start with those that might be clarified. First, the size of 3I Atlas, as I mentioned, should be larger than 5 kilometers. We don't know what it is. However, if the images indicate a much smaller size, less than a kilometer, then this tension of why are we seeing an object that is 1,000 times more massive than the previous interstellar comet, Borisov, from 2019, that would be alleviated. It's also 1,000,000 times more massive right now than Oumuamua, the first object. So, it's just puzzling. Why would the third object be so many orders of magnitude more massive than the previous ones? And then there is the jet that I mentioned, that is another anomaly, 10 times longer than it is wide, pointing towards the sun,
Yep.
very different from the tail that we often see away from the sun in solar system comets. And then there is the unusual chemical composition. The plume of gas around 3I Atlas is showing much more nickel than iron. And we find much more nickel than iron in industrial production of nickel alloys. So the question is this a techno signature? Again, we can learn more as we do some spectroscopy when it's close to Mars. And also, unlike solar system comets, the plume contains mostly carbon dioxide and not water, as many astronomers forecasted that this must be water-rich. It's not water-rich. Water makes only 4% of the mass budget of the plume of gas around it, the coma, and 87% is carbon dioxide. And then there is polarization of light from 3I Atlas, which is extremely negative, never seen before for comets from the solar system. All of these are physical characteristics that could potentially be explained. But then there are
polarization. That's how I butter the bread around the Keating household is polarization. Explain what is polarization, why it's the least understood form of all the light properties that we know about, spectrum, intensity, polarization, and almost nobody knows about it. And yet, it's incredibly important for revealing compositional details. So you should explain to the audience, what is polarization and why is that so significant, what you just mentioned?
Yes, in fact, I discussed polarization in the class that I teach at Harvard to graduate students. It's the only obligatory class in the PhD program of the astronomy department at Harvard. And it's about radiative processes in astrophysics. And last week, I discussed polarization. Polarization is, any electromagnetic wave is basically made of an electric field that is oscillating and a magnetic field that is oscillating. And the two fields are perpendicular to each other in vacuum and perpendicular to the direction of motion. Now, the magnetic field can be related to the electric field. So we just need to discuss the electric field, and because the two are always perpendicular. And the electric field could it's moving. So if you were to move with it, then you could see it, for example, oscillating up and down along an axis. That's called linear polarization. And it could also move in a circle. The vector of the electric field can move in a circle, and that would be circular polarization. And then you have combinations of the two that give you elliptical polarization. And there is also the possibility of no polarization at all, where you mix all kinds of polarizations in a way that you don't get any polarization. So the fraction of the light that is either associated with an electric field along one axis is or a circular polarization gives you the polarization fraction or the level of polarization of the electromagnetic wave. And that is important because, for example, if light is being scattered by electrons, then it depends how the electrons are moving when they scatter the light. And they produce polarization to the light if they have some geometry. And that's not true only for electrons, it's also true for any scatterer of light. And what often happens is if the geometry of the scattering material has some shape that is not spherically symmetric, you end up polarizing the light in a preferred direction. And what we see for 3A Atlas is negative polarization, which is very extreme. And perhaps nobody worked out the details. It might be related to this geometry of the jet that I mentioned of scattered light, scattered sunlight in front of the object towards the sun. We don't know it because nobody worked out what can explain this polarization. Never seen before for comets. And then I should mention there are anomalies that will remain puzzling forever, irrespective of how much data we get from the Mars orbiters or from other probes. The trajectory of 3I Atlas is aligned with the plane of the planets around the sun to within
Brian
5
shared
degrees.
the polarization.
And that has a likelihood of 0.2%, less than a percent. And so the question is, why is it aligned? If you imagine incoming objects from outside the solar system, they should not have a preferred direction. They come in all angles. And in fact, the previous two interstellar objects had a large angle relative to the plane of the planets. The plane of the planets, the ecliptic plane, is not in the same direction as the disk of the Milky Way galaxy. There is no reason for an incoming object to be so perfectly aligned. And of course, it's very fortunate for us because it means it spends a lot of time near assets that we have in space. Like it's coming close to Mars, and then it's coming close to Venus, and then it's coming close to Jupiter. That allows us to look at it in great detail because it's also a big object. So it's our fortune, but why do we have that fortune of 0.2% likelihood? The arrival time of 3A Atlas is also optimized for it to pass near Mars, Venus, and Jupiter, because these planets are moving around the sun, on a period of other years, and yet 3A Atlas comes to the right place at the right time to be close to all three of them. It doesn't come close to Earth, though, and again, one may ask why. And then finally, just this week, a few days ago, I realized that the arrival direction of 3A Atlas from the Milky Way galaxy into the solar system was coincident with the direction of the WOW signal. And that's a radio signal detected on August 15th, 1977. And it was a complete mystery where this signal came from. It's called the WOW signal because that's what the person, the observer who noticed this signal in Ohio State University Observatory, the Big Ear, just noticed an amazingly strong signal, much above the noise. But and it was clear that it's extraterrestrial, coming from outside the Earth. But it wasn't clear where it's coming from within the Milky Way galaxy. And what I realized by comparing the coordinates of where the signal came is that they are within 9 degrees of the direction from where 3A Atlas came. And 3A Atlas back in 1977 was about 600 times farther from Earth than the sun is, and about 3 light days away from Earth. And so the chance of it being aligned with the WOW signal is 0.6%. I calculated that. And at that distance, if you ask how much power is needed to emit such a radio signal as detected, it comes to about a gigawatt, the power output of a typical nuclear reactor on Earth. So,
and that wasn't just that wasn't at some random frequency, right? That was at 1420 megahertz, correct?
Yes, very close to the hydrogen hyperfine transition. And also the signal was blue shifted. So it means the source was moving towards the sun, just like 3A Atlas. The inferred speed was about 10 kilometers per second. 3A Atlas was moving at 60 kilometers per second, but it could be related to some measurement error. Also, it didn't come from exactly the same direction. So, another possibility is that it was a signal transmitted towards 3A Atlas from, another source. But This leads me to recommend to radio observers to monitor 3i Atlas for any radio signal. As far as nothing was reported so far, as far as I know, but I wrote an email to some people hoping that they will actually observe 3i Atlas in the coming months with radio observatories.
It could be possible. I mean, we could observe it even with things like the Simons Observatory. But tell me, Avi, why, when you put all these together, I think it's quite interesting that.
So, you guys could watch this whole interview if you want on Brian Keating's channel. He's pretty good. He's had Avi on a couple of times on this. But my thing with this, when I heard this whole piece, and I've heard it a couple of times the last few days, the fact that it came close from the same direction, close to the same direction, 9 degrees from the WOW signal in 1977. It's not news to me, right? It's been out for a few days that measurement was made. But when I was listening to this, it strikes me as odd that we're not attempting to do some sort of test, right, and broadcast that same exact signal at the same exact frequency that we received in 1977 back out at this object. And I know people are probably freaking out in watching this video and thinking, well, that's crazy. Why would we do that? I mean, then that's going to know we're here. Well, guys, like I talked about earlier, before I put the video on, we've been sending out radio and TV signals for like a century, like probably more than a century, and this thing it's not like it's not able to pick those up. As far as we know, like those signals are way out in space at this point. A lot of things could be picking them up, and if there's even a remote chance to me that this thing is artificial and that it came here to find us potentially based off the work that SETI's done and others, and the radio chatter and TV chatter that's out there in the galaxy already from us. To me, it makes sense. We could do one of two things. We can try to stay relatively quiet and, be scared, right, of what this might represent if it were artificial. And we could pretend there's another, well, I guess there's three, right? We could stay quiet just based on the grounds that we don't want to risk signaling this thing, and maybe for whatever reason it's not aware of all those other signals going out, that they're coming from Earth. Though again, the oddities with its trajectory and elliptical plane alignment would suggest a artificial trajectory, would suggest a intended trajectory. That's what one of the first anomalies Avi Loeb pointed out with this thing. Now, it doesn't prove that, right? There's stuff coming into our solar system all the time, some of it with alignments close to the elliptical plane, some of it without, right? Some of it on great angle. And the elliptical plane doesn't line up with the direction of the Milky Way disk, okay. But in my opinion, space is like a big pinball machine. There's probably stuff shooting around all over in different directions based on the destruction of solar systems, and stars going supernova and blowing stuff in all directions and everything else. So like, I don't think that necessarily points to this thing being artificial, but it is an oddity. It is an oddity with what we've come to expect from things coming into the solar system and from how orbits work in our own solar system. So it is definitely an odd thing, an anomaly, so to speak. But it's only an anomaly potentially because we have a very small data set. There's no guarantee that we won't find more of these things in the next few years. We've actually just gained in the last decade a lot more ability to see these objects as they enter our solar system. So there's a chance that this is not as odd as we think it is, right? It could be more commonplace. And that's the biggest argument, I think, going for a natural origin for this object, is that we really don't have a very big data set. Like, our data set's tiny. We were going off of 3 other interstellar visitors, and they've all been different to some degree, but none of them have been anywhere close to what this thing is on the anomalous scale, for all the reasons that Avi's pointed out here and in his papers. But again, that's a very small data set. That was the biggest argument I think I heard from Michael Shermer on the original interview that they had on this thing, and the debate that they had on natural versus artificial. is that we have a very small data set, and I've heard that echoed by a lot of other scientists, and I can't argue with them. They're not wrong, right? We don't know enough to say one way or another. That's a very logical approach, very conservative approach, but probably 70% the correct approach in this situation. But to me, we have added to this since that debate. We have added to this the nickel without iron. We've added to this the fact that we've never gotten a really, really strong cometary tail from this thing. Even after it got hit by a CME, we have not gotten an ending to the sunward plume in front of it that's going out. And now we have this new mass data that points to it based on its trajectory and speed and everything not changing, points to it being much bigger. So so the anomalies are they haven't died down or gone away. If that's your perception of this object, then your perception's probably a little skewed because people have been pretty quiet about this thing. The anomalies have really increased and changed, and they don't necessarily point to an artificial origin. They could also point to this being like a fragment of another planetary system that was ejected, not technically a comet because it's got heavy materials in it. It's not an icy nucleus. So it could just be an asteroid, basically interstellar asteroid or something to that degree. But it definitely doesn't point any further away from artificial. And the initial anomalies that we still have that kind of make it questionable. And I would say there's at least a 2% chance this thing's artificial. And Avi Loeb on his scale, and obviously he's somewhat of an optimist on this stuff, but on his scale it's a 2 of 5 artificial origin. So, he's got it set a little bit higher. And I guess where I'm coming from is if we have this signal from 1977 at 1420 megahertz and however many decibels, or decimals after, and we have the technology, we have the equipment to send that signal in a narrow band right back to this thing. Why wouldn't we do that? From a pure research standpoint, why wouldn't we do that? If it's natural, no harm, no foul. It doesn't matter. It's just going to bounce off and it's going to go on its merry way. Radio signal's not going to affect it one way or another. If it's artificial, it might be looking for that response. And that could be a positive thing for Earth, could be a negative thing for Earth, but we don't know. If it's artificial and it's not looking for a response, it's already got plenty of ambient human signals out there in space that are still floating around. It's already seen. So if its intent is to come here and harm Earth, if you want to put your tinfoil hat on and you want to speculate that this thing's artificial and then speculate that it's hostile, that to me that's pretty far-fetched, because if that were the case, this thing, if it had the technology to get here from somewhere else with intent, then it would have the technology to come straight to Earth. If that was its intent, it wouldn't have had to come covertly in here. It would know our technology is still relatively primitive, based on what it's seeing in radio and TV and everything else, the actual news, and they wouldn't have any reason not to just come here and do what they're going to do. And we couldn't prevent that anyway at this point. So I guess from a purely logical standpoint, going from the aspect that, from the point of view that this thing could potentially be artificial, there's still a potential artificial origin on the table. And we'll know more after all these Mars orbiters and everything take pictures. We may know for sure that it's natural at that point, which would be great. That's fine. But we also may know for sure it's artificial. And I guess my point would be there's nothing preventing us from sending this signal to this thing and seeing what the response is. If it's a natural comet, it's not going to do anything. It's not going to change trajectory. It's not going to come over and scare the crap out of us. It's just going to go on its way. If it's artificial, it may already be intending to come here. We don't know. Maybe that would be a way to say hello in a non-violent, non-threatening fashion. This is the signal that this thing, if this thing or its civilization sent that signal back in 1977, if it was artificial, then that would be a great way to, open dialogue, right? or prompt open dialogue. It would also be a way to say to this thing, if it is artificial, hey, we see you. We know you're not an asteroid. We know you're artificial. And I would think that would be a point in our favor, regardless of what the intent of this thing was, for it to know that we can see it for what it is would be a point in our favor, right? As far as our capabilities are concerned. And so it's like it's the whole you could make the whole fight or flight argument. If you speculate that this thing's artificial, what are the benefits of staying what we think is quiet, which we're not quiet at all. We're broadcasting all the time, but quiet as far as directed signals go versus directing a signal. And I would love to get some feedback. I know I don't have barely any subscribers. I haven't been doing gameplay videos, but this whole saga, this thing has really sparked my attention and creativity and imagination. So, whatever happens with it, I'm going to clarify here and say I'm not saying I believe it's artificial. I'm not saying I believe it's a comet. I'm open-minded, probably relatively open-minded for a Christian. I don't have a dog in this race, so to speak. Don't care. I just I think it's very interesting. I'm always interested in learning more about the universe that we're in. And I think it's a fascinating opportunity that if we wait a few more months, we will miss that opportunity to put that signal out there. Now, I'm saying all of this with the caveat that supposedly we're taking pictures right now, and in the next few weeks or the next few days, we will all find out a lot more about this object, and it may be completely natural and provably natural. And if that's the case, fantastic. I can't wait to see what information and data we can glean from this object as we see it go through our solar system. But the other side of this thing, if it is a natural comet or a natural fragment, I don't even want to say comet because everything I've seen on this thing does not show a cometary tail. So I don't even think classifying it as a comet makes sense. I have yet to see any pictures from NASA or from ESA or from any of these other agencies out there that show this thing with a truly cometary tail. If they exist, they have not shared them. They have continued to say this is a comet, but they have not provided evidence to show that, at least in the way this thing looks and acts. They have not provided evidence to account for these anomalies, not in a way that makes sense. The nickel without iron, their hypothesis would require theoretical processes that we have yet to see, which are perfectly possible because, again, we have a very small data set. But they're no more probable than artificial production of nickel. No more probable, in my opinion. I don't care what the AI says. I don't care what NASA says. We've never seen those processes occur in nature on this planet. We haven't seen it in solar comets. We have not seen it in interstellar objects yet. So my point is just that we don't have a natural precedent for nickel without iron. And yet all these NASA scientists and all these other folks who want to debunk any thought this thing could be artificial are throwing out all kinds of speculative ideas, speculative science, saying, oh, it's natural because this process happens in nature. We don't have an analog for that. So that's no more truth-telling than Avi Loeb coming out and saying this thing's an alien spaceship that wants to get us, which at no point has he come out and said. He has merely opened the door to the possibility that this thing could be alien, the possibility that it could be a probe, the possibility that it's not natural. And keeping an open mind when we see the anomalies like this thing has, I think is just as important a part of science as understanding, the laws of nature, understanding the laws of physics, understanding the already stated scientific fact that we have, and using that as context. I think those are both important. But I think he's been excoriated and demeaned and screamed at for his interpretation of the data without just cause, without any reason, really. Like, it's okay to have questions. It's okay to open the door to non standard ideas if you're presented with data that does not fit the standard model. And much of the data in this case does not fit our standard understanding of how comets work, of what we should see in comet spectrophagy, of what we should see of their normal trajectories of all the historical precedent that we have. These things don't line up. So he's pointing out the fact that these things don't line up. They don't mean that this thing's artificial. They just merely open the door for questions that need answers. And hopefully over the next few weeks, we'll have more answers to those questions, and we'll get to know a little bit more about this object. So I wanted to do this video today. I know it's not my normal thing. I'm normally just playing video games, but I wanted to do this video today just because I have a lot of questions about this thing. I think it's really exciting regardless of what direction it goes in, and I wanted to put out the idea that perhaps SETI or some other space agency or some organization sending a signal to this thing, if we have more indicators that it's artificial coming out of these latest observations, if we find that to be true, maybe sending a signal to this thing before it leaves our solar system would not be such a bad idea. And you know, that's just my mind. I don't let fear govern my decision-making process. But I'm just throwing that out there. I'm curious to see what you guys think. I think somebody probably, even amateur with the right technology and the right budget, and we're talking hundreds of thousands to millions of dollars, could send a signal as well. But that would be illegal under current treaties and stuff to send that signal, and you might go to prison for a long time. But there's opportunity for people who wanted to do that to do it if they don't have any regard for the limitations put on us by government. But I'm not suggesting anybody do that. I'm just saying that there's potential for that to happen, whether our government agencies choose to take that up and do it or not. There's potential for people like you and me who have a little bit more resources to do that themselves, give it enough time. And I'm sure I'm not the only one who's had this thought process, right? So on the other side of that is, like, if a government stepped forward and took that on, then, you know, potentially they could prevent somebody who is less knowledgeable, less equipped, less ready to handle the implications of what comes back from that, from doing it on their own. So that's just my take on it. Would love to get you guys feedback below, and I hope everyone has a great weekend. Take care, guys.